Namaste students. We were studying about refraction. Hope you are not bored with refraction, right? So we have seen different aspects of refraction. Now let us take a small rest and we will go to the problems. How to go with the problems. One or two problems we have discussed, sign conventions and all. Now we are with a lot more of knowledge about refraction, Snell's law and all. So we will discuss a little bit of problems. So moving on, and I've given some problems to that in that PDF form. If you have that, just open it. Otherwise we will look into these problems. We will go one by one. Now this problem here, an object is placed at a distance of 6 centimeter in front of a concave mirror, right? It is a concave mirror problem. Object is placed at a distance of 6 centimeter from a concave mirror of radius of curvature 6 centimeter. Find the position and nature and magnification of final image formed. Okay, answer is also given. Now coming back to the board, it's a concave mirror. You see the positions always in a mirror, in a lens, and okay, in both. Whenever you find out the image, please take care of the theory. You know what should be the position of the image if the object is kept at a particular place, what size of the image should be formed. All these things you must have in your mind. Then whatever the answer you get, you can analyze it whether it is correct or not. So we will go along with that. So here the problem goes like this. An object is placed at a distance of 6 centimeter in front of a concave mirror. Always draw the concave mirror such that object comes to the left hand side. So this is the principal axis, this is concave mirror, and if you incident parallel rays to the concave mirror, all the rays meet at the focus here. So focal length is this side and focal length is said to be 6 centimeters. Radius is 6 centimeters. So center will be here. Suppose focus is here, center is here. So they say R is 6 centimeter and a concave mirror of radius 6 centimeter and object is kept at 6 centimeters. So focal length is 3 centimeters. Okay, and object is kept exactly at the center because it is 6. That is what they say, right? Now, so an object is kept at a distance of 6 centimeter in front of a concave mirror of radius 6 centimeters. Right. Find the position and nature and magnification of the final image. Of course, you know, when the object is kept at C for a concave mirror, it is the only mirror which produces real image of the same size. So image is also formed at C and it is same sized but real. On the same side as the object, image is formed here only. So when you, so object distance is 6 centimeters. Now taking care about all the sign conventions. Divide this into coordinate system like this. So all the things coming under the right hand side positive, left hand side negative, because when you start from the pole, when you move to this side, you are moving in the direction of light like this. And above positive, below negative. Yes, now our radius is a negative because it comes in the left hand side, and focal length is negative, comes in the left hand side. Object distance negative, comes in the left hand side. All are left hand side. So here, and you know the result, image distance should be 6 centimeters. Simply we are solving it now. We will check whether you get 6 centimeter or not. Image distance should be 6 centimeters. And finally, you should get image distance also as negative. You know why it is so? Because image is formed in the same side. So it should also be negative. Okay, now, so formulas, 1 by F is equal to 1 by U plus 1 by V. So if 1 by F is equal to 1 by U plus 1 by V, if you substitute the values, 1 by minus 3 is equal to 1 by U, U is 1 by minus 6 plus 1 by V. V should be negative finally because you should get it in the other side. Minus 1 by 3 plus 1 by 6 is equal to 1 by V. That implies 6 common denominator. Minus 1 by 6 is brought here, it becomes plus. 6 is the common denominator. 3 2s are 2 minus 1 minus 2, 6 1s are plus 1. So that is 1 by V. Keep on writing this 1 by V always, because finally there is a chance that you will take this answer itself as V. But it is not V, it is 1 by V. So 1 by V is equal to minus 1 by 6. What does it imply? V is equal to minus 6 centimeter. Image is also formed at the same place as the object. Of course, shortcut method is simply applying the theory and getting the answer. What is magnification? Magnification is minus V by U. If you substitute this, minus V by U, minus is in its formula itself, then V by U. V is minus 6, object is distance is minus 6. So this minus is in the formula. V is minus 6, U is minus 6. So what is totally magnification? Minus 1. Why, sir, it is minus 1? Magnification 1 indicates that object height and image height are same. Minus indicates that image is inverted, it is below the principal axis. So a very simple problem, but you have to take it very seriously and work it out so that you will have the theory and answers matching each other. Then it will be, you will get the confidence that the answer is correct, and then you will proceed forward. Otherwise, while applying sign conventions, it is the confidence that works a lot. You will have to be very confident that what I put minus here is correct, this is correct, and everything. Otherwise, you won't move forward. Right, we will move on to the next question. Right, next problem. Right, yes. A person is running towards a plane mirror with a speed of 6 meters per second. What is the speed of the image with respect to the person and with respect to the mirror? Right? Okay. Speed they have asked. Of course, you can answer velocity also. If a person is running towards a plane mirror, it's a plane mirror problem, with a speed of 6 meters per second. What is the speed of the image with respect to the person, and what is the speed of the image with respect to the mirror? If mirror is also a living being, if you ask the mirror with what speed the image is running, what is its answer? Okay. In a plane mirror, coming to the problem now, so velocity of the object is 6 meters per second. That's all the data. In a plane mirror, you know that object distance is equal to image distance always. So if you are standing in front of a plane mirror like this, suppose I am at a distance of 2 meters or 6 meters from the plane mirror. If I go by 1 meter forward, image will also move by 1 meter forward. So totally between me and my image, there will be a difference of 2 meters, because image will not keep quiet. It will do whatever I do. So if I move by 1 meter forward, image will also move by 1 meter forward. So totally there will be a difference of 2 meters. Correct? Now, so we will take a generalized case. I will take all the data with 1 meters so that it becomes easy for analysis. So, or 10 meters I will take. Suppose I am standing at a distance of 10 meters from the mirror. Okay? And I will take the velocity as, I will analyze the problem, then we will go to the problem. Okay? We will have some discussion on this so that it will be helpful for entrance exam also. I am starting at a distance of 10 meters from the mirror, and I am moving at 1 meter per second towards the mirror. Say, this is the situation before you start moving, and your image is standing at a distance of 10 meters from the mirror, inside the mirror. So now, suppose there is one more person, your friend. It is you, this is you, and this is your friend. Okay, this is yourself, this is your friend. Friend is not moving. Friend is not moving towards the mirror. Now, of course, you can imagine that another friend is holding the mirror like this, standing and holding the mirror like this. Okay, the person holding the mirror. So I will call him as M, person who is holding the mirror. Now, let us see the situation after 1 second, because always remember, what is velocity? Velocity or speed is the rate of change of displacement. Displacement divided by time taken. Right? Now, if time taken is 1 second, what happens is velocity becomes equal to displacement itself. Right? If time taken is 1 second, velocity becomes displacement itself. Car is moving at 10 meters per second. In 1 second, how much distance it will travel? 10 meters. It is automatically true. So we will restrict ourselves, every discussion, everything under 1 second. It becomes, then what the answer we get itself is the velocity. So with this in mind, keeping in mind, so delta t is always made for 1 second, then velocity is displacement itself. Okay, actually displacement by 1 second actually. Your unit will not, the magnitude of displacement is equal to the magnitude of velocity. Of course, displacement cannot be velocity. Magnitude of displacement will be equal to magnitude of velocity. Okay, let the body move in 1 meter per second towards the mirror. Now what will be the situation after 1 second? Let us see what happens after 1 second. After 1 second, I will or you will move by 1 meter forward, and new distance is 9 meters. So you will move by 1 meter forward. Okay. So now your new distance is 9 meters, and your image also will move by 1 meter forward. So this is 1 meter, right? And image will also move by 1 meter forward. Don't think that we are simply exaggerating the things. It's such an easy problem. Why it is to be discussed so much? Finally it becomes very complicated. So this is also 9 meters. Image will also move by 1 meter forward. So the new distance between me and the image is, so here it is 18 meters. Last time it was 20 meters. If I look at my image, the distance has decreased by 2 meters. So if you look into your image and if you run towards the mirror, then you will find that in 1 second, these are all the stories happened in 1 second. In 1 second, the image has moved by 2 meters with respect to you. It is not by 1 meter, because you have also moved by 1 meter. Suppose your friend is in a city which is somewhat say 60 kilometers away from here. Then if you move by 30 kilometer and if he also moves by 30 kilometer, you can meet in the middle of the two cities. So actually totally displacement is 60 kilometers, because you have moved 30 kilometer, he has moved by 30 kilometer. So if you only one have to move in order to meet the other, he has to move by 60 kilometers. So the change is 2 meters. And the change is 2 meters, and 20 has reduced to 18. So what do you feel? You feel that image is running towards you with the 2 meters per second. So if the velocity of the or speed of the object is 1 meter per second, then or v meter per second, then speed of the image with respect to object. This is very important. Speed of the image with respect to object is equal to double v, right? That is equal to 2 meter per second. Am I right? Or I will restrict this to only v. So if an object is moving at v meters per second, then image will be moving with the 2v meter per second. Am I right? With respect, velocity of the image with respect to object is 2v meter per second. That means with respect to me, image is moving at 2 meter per second. Now, what is the velocity of the image with respect to mirror? With respect to mirror, if you want to know this. Now, you ask the mirror, what changes have occurred in 1 second? Total in 1 second, what are the changes that has occurred? Mirror will say, sir, initially, so mirror is here. Initially, the image was at 10 meter. Now, the image is at 9 meters. So, what is the change? Change is only 1 meter. So, with respect to velocity of the image with respect to mirror it is v meter per second. Of course, if you are strictly writing it, if you take the velocity of the object as positive, this is negative because image is moving in the minus x-axis. This is minus v. Okay? And what about this? V of v minus of minus v, 2v, like that. So, velocity of the image with respect to mirror is v meter per second. What is the velocity of the image with respect to this third person? It is also 1 meter per second, because third person will feel that it has only changed by 1 meter, because suppose the third person is at a distance of 5 meters from me, okay, from us. We are running towards the mirror. He will not move, so he will be here only, right? Initial distance between the image of this person here and the third person, your friend, is 5 plus 10 plus 10. How much it is? 25. Distance of the image with respect to the third person is 25. Now he is here only, the third person is here only, this is 5 meters. What is the distance of the image with respect to the third person after 1 second? All the stories have happened. The velocity of the image, distance of the image is 5 plus this 10, 15 plus 9, right? Correct? 5 plus 10, 15, 15 plus 9, 20, no, sorry, where did we go wrong? Yeah, this is 25, yes. 5 plus this 10, 15, 15 plus 9, 24. This is the image position. So the new position with respect to the third person is 24 meters. So distance of the image with respect to the third person is 24 meters. So how much it has changed? Only by 1 meter. So velocity of the image with respect to third person, it is very similar to the mirror holding, the person who is holding the mirror. Velocity of the image with respect to third person or friend who is not running, so it is v meter per second only. So if your friend is observing inside the mirror, then the image will be running with the same speed as the object, whereas with respect to you, it is double, because your image is also coming towards you. Now you will have different cases here actually. This is the only simplest case. I have taken enough time to explain it. Suppose mirror is running towards you. You are not running towards the mirror. Mirror is running towards you. What will be the case? We will discuss it. Okay? We will discuss it so that it will be helpful to you to carry on in the future problems. Let us see the situation. Same situation. You can take the same situation and analyze it. I am standing at a distance of 10 meters, and observer is planning to run at a speed of 1 meter per second towards the mirror. Image is at a distance of 10, this is 10 meter. This is 10 meter image. Image is here, like this, and now this is also 10 meter. Right. Now let the, not the person running, sorry, it is the mirror running. Suppose the mirror is taken with the speed of 1 meter per second towards the object. Mirror is running at a speed of 1 meter per second towards the object. If this is the case, okay. Now let us write all the conditions. Person will be here only, you will be here only, you will not move forward, and mirror will move forward by 1 meter in 1 second. So new position of the mirror is here in 1 second. So this is after 1 second. What is the story? Mirror will move by 1 meter forward, and what is the new position of the object? It is 9 meter, right? And where is the image? 9 meter from here. So image position is here, correct? Now, so you analyze the object position and image position. Initially, the distance between the object and the image, you ask the person, you ask yourself, where is the image? 20 meters, right? So 20 meters from you. After the mirror has started moving forward with a velocity of 1 meter per second towards this direction, towards you, what is the new position? New position is only 18 meters. What is the change? 2 meters in 1 second. In 1 second, everything has changed and produced a total distance of 2 meters. So if only mirror moves towards you with a speed of v meter per second, what is the velocity of the image with respect to you? It is 2v meters per second. So velocity of the image with respect to the object, you have to ask the object itself, but object is stationary, mirror is running towards you. So with respect to the object is it is 2v meter per second. If the object is, mirror is moving with the v meter per second, and it is 2v. So this is how you do, right? But this is not all, and you will have still some more cases in that. You can refer any book, or you can refer your teacher. They will teach you how to do that. But now you have to, after getting this much of information, you have to carry on yourself, so that your brain should start working. Once you get the doubts, you have to solve it with the teachers, then they will teach you what to do. So this is the way in which I solve. You can solve it in your own way, but what the thing is, it looks very simple. Running towards the mirror, image is running, what a simple problem, but it is very complicated. Now I will give you a homework. You are running towards the mirror, and mirror is also running towards you, right? I will give you a homework. Mirror is running towards you, and you are also running towards the mirror. Say same speed, v. Take it as 1 meter per second, 1 meter per second. Suppose you get the answer as 4 meter per second, then it is 4v answer. Whatever it is, I don't know how much I get. You have to analyze it. If you have any doubts, you just whatever you have worked out, and if you didn't get the answer, you put it in the WhatsApp. I will answer it, right? It is this number 94801 98001. You put it here, then I will answer you, right? So the situation is, when you are running towards the mirror, your image appears to be running with the 2v, if your speed is v. When the mirror is running towards you, you are stationary, your image appears to be running with velocity 2v. Now you are running with v, mirror is also running towards you with v. What is the velocity of the image with respect to you? One question. Another question is, mirror is moving away from you, you are also moving, towards the mirror. Same speed. What is the velocity of the image with respect to you? These two are the homeworks. So you have plenty of ideas like this, right? So I will stop at this junction about this problem. So what is the question now? Coming back to the question, going to the projector, what is the answer to this? Definitely it is see, if a person is running towards a plane mirror with a speed of 6 meters per second, what is the speed of the image with respect to the person? Speed of the image is v minus of minus v, that is 2v, that is 12 meters per second. What is the speed of the image with respect to the mirror? The person holding the mirror is not running, so velocity of the image with respect to the mirror is only 6 meters per second. Speed. Okay, so simple. It is now. Once you solve it elaborately, then it is simple. We will move to the second problem in the projector. Yeah. Now, how to solve this one? A person is a person runs towards a rear view mirror. Okay. The question itself has run away. Yeah. Now you can see it. A person runs towards a rear view mirror. You know which is rear view mirror? It is convex mirror of a vehicle with a speed of 2 meters per second from a distance of 12 meters. So you are at a distance of 12 meters from the rear view mirror of a car, say. Now what is the speed of the image with respect to another person observing the mirror? Suppose the driver of the car is sitting inside the car itself, car is at rest. Then what is the velocity of that person running from? Suppose a person is jogging outside. If you look into the mirror in your car, with what speed that image is running towards the mirror, right? What is the speed of the image with respect to another person observing the mirror? Focal length of the mirror is 4 meters. So we will come back to this problem. Easy problem, but first analysis requires some explanation. You can do this in two ways. If you want an accurate answer, you should go for one method, and if you want some almost answer, you can do it in another way. Okay, two methods, but in entrance exam you go for the differentiation of the equation. Okay, now it's a convex mirror, reflecting side is outside, this is rear view mirror. So you are sitting in a car and you are observing the, so this is your nose and you are observing the rear view mirror, and the person is running from somewhere here. So here is the person who is running and coming like this, and he is running at a speed of 2 meters per second towards the rear view mirror, and he is situated at a distance of 12 meter, I think, yes, 12 meter from the mirror. It is like this. Okay, so now yeah, what is the speed of the image inside the mirror which is running towards you like this? Image will run towards you, and in a convex mirror image is very small and it is virtually erect and all. Okay, so if you divide the whole coordinate system like this, because the object should emit the rays and they should be coming along positive x-axis, image distance should be positive because it is this side. Height, okay, height is not needed here. Object distance is negative. What about the focal length? You know, if parallel rays are incident on a convex mirror, they diverge in such a way that they appear to come from the focus. So focus is here, F is positive. Do it like this 2 or 3 times. Then you need not remember it at all. Then automatically the film will run in your brain. So convex mirror, rear view mirror, parallel rays diverge, they appear to come from the focus here, focal length is on the other side, positive. Okay, now what I'll do is, I will analyze it as I did in the previous problem. What I'll do is, just now I have told, speed is equal to rate of change of distance, and if time is, with respect to time, so time is 1 second, then the magnitude of displacement itself is speed. Okay, so I will restrict all the problem to 1 second. After 1 second, what will be the situation? I'll write. Okay, then find out the images. For example, now this is beginning. I will write this as beginning. Okay, this is the beginning. What is the image distance? I'll write it. Focal length strictly plus run surface mirror of speed, and what is the speed? Focal length of the mirror is 4 meters. Yes, plus 4 meters. Focal length of the mirror is 4 meters, and image distance is a question mark. Object distance is minus 12 meters. It is on the left hand side, and okay. Now let the person be here only, right? What is the image distance? Now my analysis is like this. In the beginning, when the person is at a distance of 12 meters, where is the image? That is the first one. I will call it as V1. After 1 second, this person will be here, right? Somewhere here. How much distance he will move in 1 second? 2 meters per second is its speed. So he will move by 2 meters in 1 second. So after 1 second, his position will be 10 meters. When his position is 10 meters, where will be the image new position? So this is V1 and this is V2. Then in 1 second, object will move by 2 meters and the new object distance is 10 meters. In 1 second, new image distance will be different because this is the new, original image distance. After some time, the image distance will decrease because object has moved forward. So what is the new image distance? In 1 second, the image has moved from here to here. That is the velocity of the image because that is in 1 second. When you calculate everything in 1 second, velocity itself will be the displacement, right? Magnitude wise they are same. So in 1 second, what is the shift in the position of the image? That is what you have to calculate. In 1 second, what is the shift in the position of the object? That you can know, 2 meters. So in this one case, what is the image distance? I will calculate this one. You know the formula 1 by f is equal to 1 by u plus 1 by v1. First image distance. What is 1 by f? 1 by positive focal length 4 convex and is equal to 1 by object is in this side minus 12 plus 1 by v1 implies this becomes plus 1 by 4 plus 1 by 12 is equal to 1 by v1, common denominator 12 and 1 by v1. I don't leave the habit of writing 1 by v1, you know for what reason, and 12 is the common, 3s are and 1s are, 12 1s are. So that implies 4 by 12 is 1 by v1 and everything is in meters, and if everything is in centimeters, never mind. Now everything is in meters. Okay, what is v1? Implies v1 is equal to, invert this, 12 by 4, that is 3 meters. So this is the first image distance. This we are in need of, first one. Now allow the person to run for 1 second. Let him run for 1 second. In 1 second he will move forward by 1 meter. Now what is the new image distance? We will see. So after 1 second, what will be the story? Focal length of the mirror will be as it is because it is the same mirror. Mirror will not keep on changing its focal length and radius as the person runs towards him or so. No, it is same. It is a constant. And what is object distance? New object distance. It is minus 10 meters because person has moved by 2 meters forward and focal length is plus 4. What is the new image distance? V2. V2 is how much? So again 1 by f is equal to 1 by u plus 1 by v. Write it as many times as possible so that formula will be very clear to you. And remember, the best way of remembering all the formulas is work out problems in those formulas. Automatically formulas will get printed. Even though you can't remember the solution of the problem, you will remember the at least formulas. So work out problems, write the formulas when you work out. That is the best way of remembering. Okay, where we are now? Yes, 1 by 4 is equal to 1 by minus 10 plus 1 by v2. So we'll bring this here. 1 by 4 plus 1 by 10 is equal to 1 by v2. That implies this is 40. I will take common denominator. 40 if I take, okay, you can take 20 also. 40 if I take, this is 10 plus 4, that is equal to 1 by v2. That implies 14 by 40 is 1 by v2, right? Then what else will remain? Yeah, v2 is equal to 40 by 14. 40 divided by 14, this is 20 by 7. So what is the answer? V2 is equal to 7 2s are 14 and 6 will remain, 7 8s are 56, 4 will remain, 7 5s are again 5 will remain, and I'll stop it here, 8s are, I'll stop it. So 7 2s are 14, 6 will remain, 56, 4 will remain, 35, 5 will remain. Okay, enough. Now, so this is the new image distance, correct? So image will shift by certain distance. 3 meters become 2.858 meters. This has happened in 1 second. So what is the difference? So shift in image in 1 second is how much? 3 minus, because original image distance is 3, minus 2.858. So what is the difference? 10 minus 8, 2, and this 9 minus 5, 4, and this is 1, this is, so I have brought 1 here, 0, 0.142. So this is the shift, therefore this is in 1 second. So image velocity or image speed is, of course, image speed will be in this direction, image will be moving in this direction when the object is running like this. If you write better, we write speed. Image speed is equal to 0.142 meters per second. Okay. Now, this is not an exact way of solving the problem, but you may solve this in the theory exam like this. No problem. You can solve this. But this is not the exact way because, see, what change occurs if we come back to the problem? Sir, suppose the object was at 10 meters. If you do the carry on this problem in the same way from 10 to 8 meters in next 1 second. In first 1 second the object moves from 12 to 10. In the next 1 second it moves from 10 to 8, right? 8 meters. And find out the image distance for 8 meters. Subtract it. Will you get the velocity of the image same? No. Because when the object is at infinity, image is formed at focus. When the object comes nearer and nearer, the image gets shifted, and that shift is not the same for all the object distances. When you are very far away from the object, what the change in image distance you get? When you come closer and closer, the change in image distances are not the same. Or in other words, change in image distance when you are at 12 meters, change in image distance when you are at 8 meters are not the same. That means what they have asked you to calculate, what is the speed of the image when you are at 12 meters. That means you should have calculated it for a very small interval. You shouldn't have calculated it for an interval of 1 second. Say 0.00001 second. In 0.0001 second, this object would have moved from 12 meter to 11.999 something like that. Within that gap you have to find out. It should be as small as possible. If the interval is very large, then the variation will be much more and the answer will not be accurate. So how to get the accurate answer? But this method is not very much wrong. It is very close to the answer. You can follow this. Correct method is differentiation. You differentiate the equation, get the answer, because it goes for very small intervals where the variation is not very much. So how to do that? I will take the equation, mirror formula, 1 by f equal to 1 by u plus 1 by v. You differentiate with respect to time, because when you take the mirror like this, object is running, object distance is a variable. It is a variable and it depends on time. Image distance is a variable, it changes with the time. But focal length of the mirror is not a variable, it is a constant with respect to time. So how to differentiate this? So shall I write this as f to the power minus 1 is equal to u to the power minus 1 plus v to the power minus 1? So we can write it like this. Now differentiate with respect to time. Differentiating with respect to time. This is a constant. So when you differentiate, and you know that d by dx of x to the power n is equal to n x to the power n minus 1. You know it, right? So differentiate this focal length, it's 0. You know this because it's a constant. It doesn't change with time. So differentiation of focal length is 0 since it doesn't vary with time. It's a constant. So what about this one? N x to the power n minus 1 minus 1 minus 1 n minus 1 minus 2 into du by dt. What is du by dt? Change in object distance with the time. That means it is the velocity of the object. So shall I write it here? It is the velocity of object, or object speed I will write, object speed. Because u is the object distance. Change in object distance with respect to time, du by dt. Plus, you have to differentiate this one, n x to the power n minus 1 minus 2 into differentiation of v, dv by dt. What is dv by dt? This is the speed of image. Image speed I could have written. Speed of image. And this is speed of object. So if I replace these formulas, 0 is equal to minus 1 by u square, I will bring this to the denominator, du by dt, object speed, minus, this becomes minus 1 by v square, dv by dt, velocity of the image. You bring this here because this is what is needed. This is what is needed, velocity of the image. So if I bring it here, 1 by v square plus, this becomes plus, dv by dt is equal to, this will minus will remain, minus 1 by u square du by dt. Okay, shall I rub this? We have the answer. I will keep the answer here only so that we can compare it. You will get a very close answer. Okay, so we will shift it here. 1 by v square dv by dt is equal to minus 1 by u square du by dt. 1 by v square, speed of what is that, image, is equal to minus 1 by u square, speed of object. Okay, now what is speed of image? That is our question. Speed of image is equal to minus, I will bring this here, v square by u square, speed of object. Now take the first case. What is the first case? When the object is at 12 meters itself, you know what is u, 12 meters, you know what is v. We got it as 3 meters, right? Coming back to the previous solution, this is needed. At that position, when the object is at 12 meters, image distance, first image distance is 3 meters. Then we shifted it after 1 second to 10 meters and a new image distance. But that one second gap is too much larger gap. So whatever the answer we have got is not more accurate. So what we can do? Speed of the image. So image speed is equal to, and we are finally retained with a negative sign. Very simple. Why it is negative? When the object is coming in this direction, image is coming in the, object is coming in the positive x-axis, image is coming in the negative x-axis. So it is in the opposite direction. Minus of v square. V square is 3 square, image distance square, divided by object distance square, 12 square, into speed of the object. Speed it is given 2 meters per second, 2. So what is the image speed? Is equal to minus 9 by, okay, I will put this whole under square, 1 by 4 square, 16. Am I right? It is 3 4s whole square, 2. This is 1 by 8 with a minus sign. So what is image speed? Image speed is minus 0.125 meters per second. See, this is actually the correct answer. At this position, remember, at this position it is correct. But at when you calculate after moving by 2 meters in 1 second, if you calculate it at 10 meters, definitely it would not be this one. It may be different. So this has given some average value of answer. This is most accurate. So velocity will not be the same. Only in plane mirror it is so, because object distances and image distances are same. So it doesn't matter whether you calculate it at some position or other position, velocity is same. But here it is not so. So this is a way of solving the problem. In the theory exam, the previous method is enough. Here you can, in entrance exam, or you can follow this also, no problem. We have, shall we move on to the next question? Okay, we will see. We will move on to the next question. Yes, we will move on to this question now. That is, a beam of light is incident on the surface of a liquid at an angle of 45 degrees. Angle of refraction is 32 degrees. What is the speed of light in the liquid? Okay, answer is given. Now how to do this? A beam of light is incident on the surface of a liquid at an angle of 45 degrees. Angle of refraction is 32 degrees. What is the speed of light in the liquid? Okay, take the paper, right, and try to solve this. Now if you come back to the board, beam of light is incident on the surface of a liquid at an angle of 45 degrees. Hope you have not forgotten what is sine 45. So it undergoes refraction like this. This is 45. Okay, and it undergoes refraction at 32 degrees. Okay, 32 degrees. Then what is the speed of light in the liquid? Okay, now you know, you can connect all the things related to this problem. That is, this is I, this is R, velocity, speed of light in this medium is V1, this is V2, and refractive indices are not given. So you are asked to find out, okay, we have, suppose this is the refractive index of the first medium with respect to air, refractive index of this medium with respect to air. So then refractive index of second medium with respect to first medium is N2 by N1. This is the only one which is in the inverted form, 2 above and 1 below. And all the other formulas, first medium by second medium, sin I by sin R. Velocity of light in the first medium, speed of light in the second medium. So speed of light in the first medium to the speed of light in the second medium ratio. Now I think you can connect these two. These are the two things which can be connected, V1 by V2. Okay, directly writing, and it is beam of light is surface of a liquid. It is given, it is incident from the surface of a, towards the surface of a liquid. What about the first one? Nothing is referred. It is air. You need not worry about that. So you can write C by V. What is the speed of light in the liquid? Sin I, sin 45. By sin R is sin 32 is equal to C by V. So we will have to have theta, sin theta table. We have to have sin theta table. Sin 32 we have to have. So take a log table and be ready with this one. Sin 3 into 10 to the power 8. What is the speed of light in the medium? Right? Vm you can write, or you can simply write. So we want sin 32. You have to go for sin 32. Yes. Okay. Natural science. And you know what is sin 45? So if you write the value, sin 45 is 1 by root 2, 1 divided by root 2, and sin 32 is 1 by, don't know, we will see that, 3 into 10 to the power 8 by V, and so this we have to substitute. So going to the sine table, you can see the sine table here. Sin 32 means you have to look into at 32. So be ready with the log tables with you. Every time I can't show it to you. Sin 32 degrees 0 minutes. Do you get it here? It is 0.52992. It is here. So if you want to know 32.5 degrees, for example, where you will go, 0.5 degrees 30 minutes. So 32 degrees, 30 minutes is here. Half degree. But now it is only sin 32 degree. 32 degrees 0 minute here. So it is 0.52992. Correct? You know sin 30 is a half, right? Very close to half it should be. So just go to sin 32 first row, that is 0 minutes. Suppose you are asked to calculate sin 32 degree, 0.5 degrees, 32.5 degrees, then it is this one. 30 minutes means half degree. So it is 32 degrees 0 minute now, 0.52992. So we can write the answer here now, 0.52992. You have to get the answer. I don't have calculator here now. You just check it. What is the speed of light in that medium? V is equal to, speed of light in the medium is equal to So you can bring V here, 3 into 10 to the power 8 into root 2, so everything comes to the numerator. So V is equal to, V here, 3 into root 2 into 0.52992, 0.52992. So into 10 to the power 8, that's what you have to write. V is equal to, answer is written in the problem. I will approximately do it like this. Let us check. You check it in the calculator. 1.414 root 2 into 0.5, right? 0.52992. Okay, 99 actually you will get 10 to the power 8. So the answer will be, you see, I will take this as almost 0.5, okay? Almost 0.5 means half. Half of 1.4 is 0.7. 0.7 into 3 means it is almost 2.1. What is the answer given? 2.24, yes. You check it in the calculator. This is 2.24 into 10 to the power 8 meters per second. Check it, I didn't bring the calculator. Okay, so I did it like this. 0.5, half of 1.414. Half of 1.414 is this 0.7. 0.7 into 3, 2.1. This is 2.24. Yes, answer is correct. Check it. This is how we do, right? Okay. Moving back to another problem. Yes. Here also you require, okay, you see the problem first. A ray of light enters a glass slab, making an angle of 30 degree with the normal. A ray of light enters a glass slab, making an angle of 30 degree with the normal. Calculate the angle made by the ray within the glass if the refractive index of glass is 1.5. See, it is given, refractive index of glass is 1.5. What do you mean by that? With respect to air. It is not mentioned, need not be mentioned, it is quite common. So, ray of light enters a glass slab, making an angle of 30 degree with the normal. Calculate the angle made by the ray within the glass if the refractive index of glass is 1.5. Okay, we will come back to the board now. A ray of light is incident on the glass such that the normal to the glass slab makes an angle of 30 degree. So it makes an angle of 30 degree with the normal. This is I. Calculate the angle made by the ray within the glass if the refractive index of glass is. So this angle, what is the angle? And this is 1.5. This is refractive index of glass with respect to air. And this is like enters a glass slab making an, okay, this is air. And you know that refractive index of air is 1. Because you have to compare air with the air itself. Velocity of light in air divided by velocity of light in air. That is 1. So if it is this is air, then the light would have moved straight, and sin I by sin r is sin 30 by sin 30. So it is 1. Okay. Refractive index of air is 1, and now you are asked to calculate what is r. You apply that cross multiplied general law. Refractive index into sine of the angle. Refractive index into sine of the angle. That will do. So 1, so I will write n1 sin I is equal to n2 sin r. What is n1? 1. Sin I, sin 30 is equal to n2 is 1.5. What is sine? Sine don't know, sin r. Sin 30 degrees half, 1 by 2 is equal to 1.5 sin r. So what is sin r? Sin r is equal to, okay, sin r is equal to 1.5, here it comes to 3, right? 2 into 1.5, 3. What is sin r? Sin r is equal to, we need log table now. We want 0.333, right? Sin r is equal to 0.333. R is equal to sine inverse of 0.333. What is the answer? Answer is 19.5 degrees. Let us see whether we will get it or not. 0.333. So how to search 0.3333 in sine? We don't have 0.333 here. We have to go back, I think. It is less than 30 degrees. Sine 30 is 0.5, right? But this is 0.333. So it will be less than 0.33. You have to go to the previous page. Yeah, previous page. You have and yes, 0.333 or search here, somewhere here. I think we get it here. Yeah. Yes. Right. 1 minute. Yeah. 0.33. Yes. You will get it here. 0.333. Where is it? See, 0.32557, 0.32832, 0.33. Here it is. This is enough for us. 0.33381. That is enough. Can you see this? Is it? Okay. 0.33. It is 19 degree and 0.33. This is enough for us. And where is it? It is in the 30 minutes. What is 30 minutes? It is like hours and minutes. When you say 30 minutes, it is half an hour. 15 minutes, 0.25 hours, 1/4 of the hour. So now if you want to see 0.333, 19 degrees. Here is a 0.32, 0.328, 0.331, 0.333. That is enough for us. We are very close to the answer now. This is 0.336. So this will be the best answer, most suitable answer. You need not go for a very accurate answer in degrees and minutes. This is enough. Where is it? This number, 0.3333. 19 degree, and this is in 30 minutes. What is 19 degrees and 30 minutes? 30 minutes means half degree. See, you have to write it like this. It is like you observe a clock. 60 minutes, 1 hour. Correct? 30 minutes, half an hour, 0.5 hour. Half an hour is 0.5 hours. And 15 minutes, it is 1/4 of an hour. Right? That is 0.25 hours. 1/4 of an hour. So in the same way, you can write this as so 19 degrees, it is 30 minutes, 19.5 degrees. 19.5 degrees. That is what we have got. 19 degrees, 30 minutes. Remember, when you write time like this, say 1 hour, 30 minutes. 1 hour is different, 30 minutes is different. If you want to club 1 hour to 30 minutes, you have to add 1.5. Okay? So that is answer. Angle of refraction. So we will, so that is 19.5 degrees. We have that answer. So we will see the next questions in the next session. Okay? We will stop at the moment. We will come back with a few more problems. Right. Thank you. Hope you are working out some other problems also. Thank you.